Hello everyone, welcome to my channel GVS Chem. In this video, let us discuss Aldol condensation. Please subscribe to my channel, like, share and comment on my videos.
Aldol condensation. In this video, let us learn about Aldol condensation. What is Aldol condensation? Aldehydes are ketones having at least one alpha hydrogen undergo condensation in the presence of a dilute alkali. Aldehydes are ketones having at least one alpha hydrogen undergo condensation in the presence of dilute alkali to form beta hydroxy aldehyde or ketone. Beta hydroxy aldehyde or ketone. So aldehydes are ketones having at least one alpha hydrogen undergo condensation in the presence of a dilute alkali to form a beta hydroxy aldehyde or ketone. Now let us try to understand with an example. This is CH3C double bond O single bond H. What is this substance? Acetaldehyde or ethanol plus hydrogen CH2CHO in the presence of say NaOH. See, this is a functional group. Functional group here is CHO aldehyde and this is functional carbon. The carbon which is adjacent to functional carbon is known as alpha carbon. Hydrogens present on alpha carbon are called alpha hydrogens. So this is alpha hydrogen, right? So aldehydes are ketones having at least one alpha hydrogen. So since alpha hydrogen is there, therefore this reaction can be carried out. In the presence of dilute alkali, what will happen here? This pi bond shifts to oxygen. Therefore, this hydrogen comes and attacks this oxygen, and this carbon, alpha carbon, comes and attacks this carbonyl carbon. That means one alpha carbon of one molecule attacks on the carbonyl carbon of another molecule. Therefore, we get this is CH3C. This becomes OH, and hydrogen here CH2CHO. So this is the product. Now this is a carbonyl, this is a functional carbon, this is alpha carbon, this is a beta carbon. So since a hydroxy group is present on beta carbon, therefore this is known as beta hydroxy aldehyde. And what is the IUPAC's name? This is 1, 2, 3. Hydroxy group is present on third carbon. Therefore, this is 3-hydroxy butanol. Now let us see the mechanism of Aldol condensation. Mechanism is the detailed discussion of a reaction in different steps. So here in step 1, this is alpha hydrogen plus OH base. Therefore here this becomes CH2 minus CHO. So here as OH takes alpha hydrogen, so as OH takes alpha hydrogen, therefore we get a water molecule, and of course this is negatively charged ion, that is anion. This ion is known as enolate ion. Since negative charge is present, this is nucleophile. This is nucleophile. So this nucleophile attacks another carbonyl compound. Therefore, this is CH3 plus CH2 minus CHO. So this is a nucleophile. So here, this what happens? This comes under attacks here. Therefore, this bond shifts in this manner. So here, in this way, this is CH3 CO, negative charge here. This is CH2 CHO. So this is the intermediate product forms. So this product, this is step 2. Now in step 3, this substance, this intermediate, CH3CO, hydrogen, CH2, CHO, it takes a proton from water. So this takes species takes a proton from water. Therefore we get CH3, COH, hydrogen, CH2, CHO plus OH minus is formed. So this is the final product. Therefore this is a beta hydroxyaldehyde. So this is the condensed product. This is known as condensed product. Or it is also called as aldol. Condensed product or aldol. Now let us take one more example with the ketone. So this is CH3 C double bond O CH3 plus hydrogen CH2. So this is also acetone molecule, but for understanding the bond shifting we wrote in this manner. Therefore this is double bond CH3. So here in the presence of a dilute alkali NaOH, so this bond shifts here, this hydrogen attacks here, therefore this comes and attacks. So what do we get here? This is CH3 CH3, this is OH, this is CH2, this is C double bond O CH3. So what is this substance? This is functional group. Then the carbon next to functional group is known as alpha carbon, and of course this is a beta carbon. Therefore this is beta hydroxy ketone. What is the IUPAC name? Numbering is from this side 1, 2, 3, 4. Therefore this is 4 hydroxy 4 methyl pentan, because 5 carbon atoms are there, pentan 2-one. So this is one more example for aldol condensation taking ketone. Now here this beta hydroxyaldehydes are ketones. From this we get one more substance here. Therefore this is CH3 COH H. This CH2 I am writing this as H and H. Therefore this is C double bond O CH3. So this is dehydration takes place in the presence of a concentrated sulfuric acid and heat. This is dehydration. Dehydration means water molecule is removed. So this is here, this water molecule is removed. Therefore this bond shifts here, this bond shifts here. This becomes pi bond. So this is CH3 CH double bond CH C double bond O. This is CH3. So what is this substance? This is a functional carbon alpha. This is alpha carbon. This is beta carbon. Therefore unsaturation is in between alpha and beta. Therefore this is referred as alpha beta unsaturated, alpha beta unsaturated ketone, alpha beta unsaturated ketone. So what is the name of this substance? Numbering must be given from this side, since the functional carbon must get the least number. Therefore the double bond is present on third carbon. Therefore this is a pent 3-ene 2-one. Pent 3-ene 2-one. So this is the product of dehydration. Now let us see the cause of acidic hydrogen. Why the alpha hydrogen becomes acidic? Why is acidic? See here, this is hydrogen CH2 CHO. So in the presence of a base, therefore this gives CH2 minus. So here this becomes a negative charge. This pi bond shifts to oxygen and this negative charge shifts here. Therefore this becomes this is CH2 double bond C single bond O negative charge and hydrogen. So what happens? These two are in resonance. Therefore the enolate ion is resonance stabilized. That means after removing this alpha hydrogen, because this hydrogen is removed, therefore this is referred as acidic. This is acidic in nature because this hydrogen is removed very easily. So the leftover ion is resonance stabilized. Since the leftover ion is resonance stabilized, therefore this hydrogen is removed easily. Therefore the alpha hydrogen becomes acidic in nature. In the two examples what we discussed till now, both the molecules undergoing condensation are same. That is either acetaldehyde molecules or acetone molecules. Now let us see one more example. So here two molecules are CH3CHO and this is one molecule, this is acetone molecule and this is acetaldehyde molecule. Acetone molecule and acetaldehyde molecule. So this condensation, here also condensation takes place. Therefore this is cross-Aldol condensation. So here, so this becomes, let us write this as a C double bond OH. So this bond shifts here, this comes and attacks here, this comes and attacks here. Therefore we get, this is CH3 COH hydrogen, this is CH2 C double bond O CH3. So what is the name of this substance? This is 4-hydroxy pentan 2O. Now, is there only one possibility? No. See, if we reverse this, suppose if we take this molecule here and this molecule here, then what is the substance we get? This is CH3 C double bond O single bond CH3 plus HCH2 CHO. So this bond shifts here, this comes and attacks here. Therefore in this manner, in the presence of dilute alkali, therefore we get CH3 COH CH3, this is CH2, this is CHO. Now what is the name of this substance? This is butanol. Only 4 carbon atoms are there in the long chain. Therefore this is 3-hydroxy 3-methyl butanol. So two different substances are found. Now is there any other possibility? There is another possibility also, that is, instead of condensing these two molecules, only 2 molecules of acetaldehyde may undergo condensation and only 2 molecules of acetone can undergo condensation. So under such condition, therefore one more reaction is CH plus CH2CHO. Therefore bond shifts in this manner, like this, in the presence of NaOH. Therefore, what is the substance we get? CH3COH, and here hydrogen, this is CH2CHO. Therefore, this is beta hydroxyaldehyde or 3-hydroxypropanol. Now, one more possibility, that is with two acetone molecules. So here, this is CH3 plus CH3, C double bond O, single bond CH3. Therefore, this bond shifts here. This hydrogen shifts and attacks the oxygen, and here this is 2. So this CH2 group and comes and attacks again. Therefore, we get in the presence of dilute alkali. Therefore, this is CH3, CH3 here, OH, CH2, C double bond O, CH3. So what is the name of this substance? 4-hydroxy 4-methyl pentan 2-one. So this is 4-hydroxy 4-methyl pentan 2-one. So in this cross Aldol condensation, when two different substances are taken, the number of different substances formed are 4. Therefore, the question may be asked as, how many number of different products are formed during the reaction between acetaldehyde and acetone? Answers may be given as 1, 2, 3, 4. Therefore, answer is 4. Now, in all these examples, both the reacting molecules have alpha hydrogen. Now, let us see one more different example. That is, out of two molecules, even if one molecule doesn't have alpha hydrogen, if the other molecule has alpha hydrogen, that is enough to undergo Aldol condensation. Therefore, this is C double bond O H. This is benzaldehyde. So, benzaldehyde without having alpha carbon, alpha hydrogen, and acetaldehyde has alpha hydrogen. Therefore, the reaction takes place. This double bond shifts, and this hydrogen, alpha hydrogen, attacks on oxygen, and the CH2 group attacks on the carbon atom. Therefore, the substance is, this is COH, this is hydrogen, CH2CHO. So, what is this substance? Name of the substance is 3-hydroxy propanol, 3-hydroxy propanol. This substance is not stable. Therefore, this hydroxy group and hydrogen present on the alpha carbon, they are removed as water. Therefore, in the presence of a concentrated sulfuric acid and heat, water molecule is removed. Therefore, this becomes CH double bond CH2CHO. So what is this substance? Name of the substance is, this is propane. So on propane, phenyl group is present on third carbon. Therefore, this is 3-phenyl prop 2-ene. 3-phenyl prop 2-ene. Common name is cinnamaldehyde. Common name is cinnamaldehyde.